WLED has support for numerous types of peripherals to extend your LED projects. In this video, I'll cover how to wire each one to your controller and then the steps to configure various types of components, including buttons, switches, motion sensors, relays, and more. No custom compiling or coding needed. At the end, I'll show an example with 7 different types of components attached simultaneously to a single LED controller. Hi and welcome to Resin Chem Tech. For today's video, I'm going to be using a standard WLED controller using an ESP32 installed with the latest production version of WLED. Now, while it's possible to use a lot of other types of peripherals if you download user mods and compile your own version of WLED, or if you use a fork of something like Moon modules, what I'm going to show today will work with a standard version of WLED that you can install directly from the web browser. Be sure to check the video description. There you'll find a link to a written guide of this project that will have copies of all the wiring diagrams that I show, information on the configuration steps in WLED for each component type, proper selection of GPIO pins, links to all the parts that I show, and additional information I just didn't have time to include in the video. Of course, if you're interested in a particular component type, you can use the links down here along the video timeline to jump to that particular component. But if you stick around to the end, you'll see an example of how I create a Franken-Controller where I connect 7 different peripherals to a single WLED controller. This is the breadboard version of a standard WLED controller I'm going to be using today. I'm not going to go over step by step how to build the WLED controller. If you've never built one before, I have another video that will show you how to build this, install and configure WLED in about 15 minutes. So I will assume that you're already able to build a WLED controller. Now, if you have watched that other video, you will see that this looks slightly different. It is wired exactly the same, but I'm using a 30-pin ESP32 board here. The other thing I've done here is I have split out my 5 volts on one side, my 3.3 volts on the other side to create a couple of power rails. This will allow me to connect multiple peripherals or components since I've only got one 5 volt and one 3.3 volt pin available on this board. I've gone ahead and installed standard production WLED on here, and the current version of that at the time of this recording is 0.14.1. Sorry to break in here for a moment, but naturally, as soon as I finished the recording for this video, WLED released version 0.14.2. Now, it primarily contains bug fixes and the ability to double the clock speed on an ESP8266, so I expect everything in 14.2 will work exactly like it does in 14.1, but I did want to mention that a new version has been released. I did opt to add in the audio reactivity since it's now available to install directly from the web. Previously, you had to download that and compile your own, but since it's now available, I went ahead and added that in here so we can also explore connecting microphones and using sound reactivity. Most everything I show today will work with the ESP8266 as well as the ESP32, except for audio reactivity. Audio or sound reactivity is only supported now on the ESP32, so you won't be able to use a microphone if you're using something like a D1 Mini. And of course, your GPIO pins are going to be different. Even different ESP32 boards break out different pins, so your GPIO pins that you have available might not be the same as mine. In most cases, that's fine. You can use other GPIO pins and just tell WLED which ones you're using, but be careful, all GPIO pins are not created equal. You could do something like connect a switch to the wrong GPIO pin and prevent your board from booting. If you want to know more about the GPIO pins and choosing the proper ones, please see my written guide to this particular project for more details. But let's get started by connecting what is probably one of the most common and useful peripherals to your WLED controller, and that is a simple push button. Adding a simple push button to your controller, especially for task lighting like under kitchen cabinets, provides a quick and simple way to toggle your lights off and on without needing to pull out your phone, use a tablet, or yell at a smart speaker. And other family members may thank you for this simple option. But of course, you aren't limited to just toggling the LEDs off and on with a push button. A push button is also one of the easiest connections you can make to your ESP or your WLED controller. We only have 2 wires here. One of them we need to connect to a GPIO pin. I'm going to connect mine to GPIO 18, and the other one simply connects to ground, either to your ground pin, or in my case, I'm going to connect to the ground on my power rail here. Now, I'm using a normally open push button. You can use normally closed push buttons. Just be a little bit careful if you're going to use the normally closed button as to which GPIO pin you pick, because you can actually prevent your ESP board from booting if you connect it to the wrong GPIO. Also note I have my board powered down here. Anytime you're connecting or removing connections to your controller, you should always unplug the power. But now that I've got this connected, I can go ahead and connect my power back up again. To define our button WLED, we just go to the config menu, select LED preferences. Now that might seem like a weird spot to put your buttons, but this is actually the LED and hardware setup page. If you scroll down, we see we have 4 slots for buttons. We can use any of these, but button 0 has a couple of special uses. I'll talk about it in just a second. All we need to do is select the GPIO pin that our button is connected to. In this case, it's GPIO 18, and we need to tell it that we're using a push button. Now, if you're using a normally closed button, you probably want to select push inverted. And I'll talk about these other types in a few minutes. But we'll select push button and we'll go ahead and save that. Now, slot 0 comes with some predefined actions for your button without you doing anything else at all. When using the button 0 slot to define your push button, the default actions are a single press will simply toggle your LEDs off and on, and a long press or press and hold will actually just select a different random color for your LEDs. It doesn't currently have a default double press action. There's one other special feature about the button 0 slot, and that is if you push and you hold the button for more than 6 seconds, it's going to reset your Wi-Fi and start rebroadcasting the WLED hotspot. In addition, if you push and hold that button for more than 12 seconds, it's actually going to erase the flash on your ESP board. So if you're putting this into a situation, maybe a small child's room, where they might have a tendency to want to push and hold that button, you might want to use a slot for your push button other than button 0. And of course, that's easy enough to do. We will just set these back to disabled, and we'll go down here and say we're going to use button slot 1 instead. Now, that doesn't have the reset if you hold the button down, but it also has a couple of different default actions. And this applies to buttons 1, 2, and 3. When you're using button slots 1, 2, or 3, the default actions for the push button are now a single press will simply cycle through and change the effects at random so you can select different effects. A long press will actually ramp up the brightness. Probably can't see that too well on the camera, but it's definitely getting brighter. And a double press will actually just change the color palette to a random palette. So again, those are the default actions for slot 0 and slots 1, 2, and 3. What if we want to do something with our push button that isn't one of these default actions? To create custom commands for our push button or our other peripherals, we're going to make use of WLED presets. Now, you may be familiar with presets for saving kind of your favorite effect with your own custom colors and speed and brightness, but you can also create a preset that consists of commands. You click a preset button, you simply uncheck the use current state, and now provides you with this API box where you can enter in commands. And there are a lot of commands available. I'm going to show just a few examples, but check out the WLED website for a full list of these commands. Also note that you can enter them in the HTTP API format, or for even more control and more options, you can actually use JSON. Again, that's all described on the WLED website. The important thing here is this ID number. That's what we're going to need to use for our custom commands for our buttons. I've created just a few examples here, and these are really simple ones. So in this first one, all I'm going to do is I'm going to set up a command in here to toggle the state of the LEDs, to turn them on and turn them back off again, kind of like we had for that default option when we used the button slot 0. I've also created one here that's going to allow me to loop through my preset list. So I'm going to start with preset 1 through preset 6, and every time the button is pressed, it's just going to loop through to the next one, and it will cycle back to the first one when it hits the end. The final one I've created here is just going to run a particular preset, in this case, solid white. I could use the 6 here, or I could use the 103 for my command. This is just showing you an example. You could also launch a playlist using this same command. Now, this isn't meant to be a WLED tutorial, but just know that you need to set up presets for whatever commands or actions you want to use with buttons or your other peripherals. Once you have those defined, we need to come back over here to config, but this time we're going to go to time and macros. If I scroll down, there are my 4 button slots, and anytime you see a 0, it means it's going to run the default action. Now, I'm still connected to button 1. And remember, the default action for a short press or a single press for button 1 was to simply select a random effect. Instead, I'm going to set this to my preset of 101. In that case, that's the toggle to turn the lights off and on. So now button 1 will work just like the default action did for button 0. For my long press, I'm going to set it to my preset 102. That's going to cycle through my presets instead of just random effects. And for the double press, I'm going to set that to 103, which is just going to select a default white for the LED strips. So I'll go ahead and save that. And then let's go over and take a look at the actual strip and use of the button now that I've assigned my own presets. So back over here on the WLED controller, this is the same button, same GPIO pin, and it's still defined in button slot 1. Now if I just give a single press, instead of selecting a random effect, it's going to toggle my LEDs off and on just like it did with slot 0. A long press will actually loop through my different presets. You can see how it's looping through those. And if I do a double press, it's actually going to select solid white. And again, I can toggle back off. So using these presets, you can define your own custom actions for each of the 3 types of button presses. What if 3 actions aren't enough? We'll simply wire up a second push button to a different GPIO pin, come in here, define that, save it. Now I have 3 additional actions that I can assign to this second button. So theoretically, you could connect 4 buttons and have up to 12 actions that you can assign. But enough about buttons. Just realize that whenever I talk about other peripherals here and we talk about assigning actions, we're going to be using those WLED presets to do that. Next, let's talk about switches or toggles. This is very similar to a button, except obviously when you flip this on, it stays in the state and doesn't return to the other state. Now I'm using a 12 volt toggle that I just happen to have laying around here, so I won't be using the third terminal to light up the little LED. I certainly could, but I just need 2 terminals here, and it's connected and configured very similar to a button. I have one wire that I connect to a GPIO pin. In this case, I'm going to use GPIO 19. Now this is a case where you have to be very careful about your GPIO pin selection. Selecting the wrong pin, and if your switch is in the wrong position, it can actually prevent your ESP board from booting. Again, check out my written guide where I talk more about proper selection of GPIO pins. The other one, we just connect to ground just like the button. That's all there is to the physical connection. Now we just need to go set it up in WLED. Back on the LED and hardware setup page, you can see I've moved my original push button back to button slot 0 here. When I add my switch to button slot 1, once again, I just need to tell it the GPIO pin that I'm using, come over here and say I'm using a switch and save. Like push buttons, there is default actions assigned to a toggle or a switch, and you're probably not surprised to figure out that those default actions are to toggle your LEDs on and toggle your LEDs off. But just like a push button as well, you're not limited to those default actions. Back over on the time and macro page, this is where we can set, again, custom actions via presets for our button 1. Now do note, if you look right here at the top, you'll see that your push buttons have 3 different actions, but your switch only has 2 actions when it goes from on to off and off to on. There's nothing available for such a thing as a double press for a switch. So if I really wanted this to run a particular effect or run a particular preset, I could set this to a value and it would do that when I flip the switch on, or in this case, flip the switch off. But I think for a switch, the most common thing is to just toggle the LEDs off and on. But I did have my button set to also do that for a short press. So now I no longer need that. I can set that to a different preset value for something like increasing brightness. Now I have this configured again, so my toggle will simply toggle my lights off and on, but my button press, instead of toggling on, I can now actually increase the brightness, and I still have my other things such as a long press or a double press. Buttons are probably a little more common than toggles or switches, but a toggle or switch can be really handy in a situation where you might have family members that don't remember the difference between a single or a double or a long press, and they just want a simple way to be able to turn the LEDs off and on. And just like buttons, if you have a need for it, you can hook up more than one toggle, up to 4, to your WLED controller if you have a special need. The next peripheral is an interesting one, and that is a PIR motion sensor. Now, this is the first peripheral we've talked about so far that's actually going to require power. And the one I'm using here, an AM312, will actually work off of 3.3 or 5 volts, but always check your pin out and power requirements because, as I showed in my previous video on motion and distance sensors, if you get the polarity backwards on this, you're very likely going to see some magic smoke. But I'm going to go ahead and power this off my 3.3 volt rail over here by connecting it to my 3.3 and ground. And then all I have to do is connect my data line to a GPIO pin. In this case, I'm going to be using GPIO 17, which on my board is actually labeled TX2. Back over on our WLED hardware page, I can pick any button slot. I'll just pick button slot 0. Once again, I tell it what GPIO pin I'm using. In this case, it's 17. But now with PIR sensors, you have a couple of different options. The first one is to define it as a switch. When defined as a switch, then whenever motion is detected, the LEDs will be turned on, and when motion clears, they go back off again. But notice that this particular sensor has a very short cooldown period, so the lights don't stay on for very long. Of course, you could use a different type of PIR sensor, something like a HCSR 501, where you can actually adjust that period of time that would keep your lights on longer. You could even use something like a microwave radar detector that has an adjustable cooldown or active period. Now if I come over and take this same PIR sensor and I switch the type from switch to PIR sensor, it now gives me the ability to have two different actions I can assign. So now back over on my time and macros page, I can set two different actions for when motion is detected and for when motion clears. So just as kind of a silly example, remember I've got my PIR sensor defined in the button 0 slot. I'm going to say when motion is detected, I want it to run my command that's going to cycle to my next preset. Well, I still need something to stop those LEDs from going off as soon as motion clears, so I have just kind of a dummy preset defined that's really just going to set the brightness level to the standard default brightness that I'm using. And I can go ahead and save those. With those actions now defined, now whenever motion is detected, instead of the lights turning off and on, they're actually going to cycle through my presets. And also note that the LEDs don't turn themselves off when motion clears, and that's because I've got that default action to just set the brightness to the same brightness I have for all of my presets. So there's a lot of things you can do with the motion detectors and the custom actions other than just turn the LEDs off and on. And do note that, like with buttons and switches, I could connect multiple PIR sensors. So I could have one, say, at the end of a hallway and the other one at the opposite end or at the top and bottom of staircases. Set them both to toggle the LEDs. As I walk past one, it would turn the LEDs on. When I walk past the other, it would turn the LEDs off. Now, there are some limitations to that, and you still have to deal with the cooldown period. And at this point, WLED doesn't have an automation engine, so you might need something like Home Assistant to do the more fancier stuff. And there are also user mods for things like stair lighting, but we're talking about here what we can do with standard WLED without any user mods or compiling our own version. So at this point, everything we've talked about with buttons, switches, and PIR detectors are all binary sensors. So you're not limited to just these. Really, anything that can put out a 3.3 volt binary data signal that you can connect to a GPIO pin on your ESP board can be used to control your LEDs through custom actions. So for example, if I have something like a digital light level sensor, this will put out a high or low 3.3 volt signal on the data pin based on whether the light is above or below a certain threshold, which can be set here. So I could easily connect this to a GPIO pin, go into WLED, configure this as something like a switch, and then have it be able to turn my LEDs on when the light drops below a certain level and turn them back off again when the light rises above that set point. So just know that you aren't necessarily limited to just these types of binary sensors. Any binary sensor that can be connected to a GPIO pin can be configured and used with WLED and those custom actions through presets. The last button type I'm going to cover is the analog button. And what we're really talking about here is a potentiometer. It's not really a button, but you use one of the button slots to define it. And it's analog because we're actually going to connect the output of this to one of our analog pins on our ESP board and not one of the digital GPIO pins. Now, since our pins are only 3.3 volt tolerant, we're going to connect up our two outer legs of our potentiometer to 3.3 volts and ground. Now, the WLED documentation recommends using at least a 10 kilo ohm potentiometer. I'm using a 20 kilo ohm here. But we're going to take our output and we're going to connect to one of our analog GPIO pins. Now, if you're using an ESP8266, you only have one pin available, normally labeled A0, but you have a number of analog pins available on an ESP32. However, there is a restriction that you've got to use one of the ADC1 pins. The ADC2 pins can't be used at the same time that Wi-Fi is active. So I'm going to pick one of the ADC1 analog pins. In my case, I'm just going to pick GPIO 34. And that's all we need to do for our wiring. Now we just need to go over and configure it in WLED. So once again, we come back over to our LED and hardware page, down to our button slots. And once again, I need to tell it which GPIO pin I'm using. In my case, I'm using GPIO 34. Notice this is marked as a read-only pin. And I'm going to tell it that I want this to be analog. Now we have to go over to the time and macros page and tell it which property we want this analog button to control. Again, I'm hooked up to button 0. We always set the short and the long to 0, and then we specify a value in the double column based on what property we want to control. Now you control things like the brightness, the effect speed and intensity, but note that some effects like solid don't really have a speed. The most common one here is going to be control brightness, so I'm going to put a 250 in here, and I'm going to go ahead and save that. So now what I have is I basically have a variable brightness control. I can use this potentiometer to actually control the brightness of the LEDs. I do note that by default, WLED will turn the LEDs off at the extreme ends, either end of the potentiometer, but you can change that behavior by adding a fixed resistor. And the WLED website talks about the resistor size based on the potentiometer that you're using. You can also change your range by changing the potentiometer or adding a fixed resistor. If you do find that the brightness is backwards, when you're turning the knob up, the brightness is going down, you can either reverse your positive and negative on the potentiometer, or you can go in and select analog inverted in WLED. But it does give you a nice variable control for some features like brightness, speed, intensity, and a few others. So that covers most of the button and binary sensor types you can add to your WLED controller. There is one type left listed here, and that's touch. You can add a touch control as well, and most of your ESP32 boards have touch-enabled pins. I'm not going to go over that particular option here. If you are interested, check out the official WLED website. Instead, I'm going to put this back to being unused, and we're going to move on to the next type of peripheral, which is an IR receiver, so that we can add an IR remote to control our LEDs. Adding an IR receiver can be a simple and inexpensive way to add remote control capabilities to your LED display. This can be especially handy for guests, other family members, or even younger children to allow them to have almost complete control over the LED display without having to use a web interface or memorize a bunch of button sequence presses. WLED has built-in support for a number of different types of remotes. This is the one I'm going to be using today, but note that I have the ability to reprogram these keys, or if I can get the codes from any other IR remote, you can use just about any IR remote that you have with WLED. And I'll talk about the remotes and the codes after we get the IR receiver hooked up and tested. This is the IR sensor I'm going to be using. It's a KY022 module. They're inexpensive. You can find them for $1 or less, and it's also very simple to hook up. Now, always check your documentation for your particular receiver, but this one will run off of 3.3 or 5 volts, so we just have our voltage, our ground, and a data signal out. So it's very easy to hook up, much like the buttons or a PIR sensor I showed previously. Since my particular receiver supports 3.3 or 5 volts, I'm just going to go ahead and hook mine up over here to my 5 volt rail this time instead of using the 3.3, but you could use 3.3 as well. And I'm going to take my data and I'm going to hook this one up to GPIO 04 in this case. Again, any appropriate digital GPIO pin is acceptable. Back over in WLED, again, once under our LED preferences or our LED and hardware page, you scroll down and right underneath where we defined all of our buttons before, you'll see an option for IR. All I've got to do once again is select the GPIO pin I'm using. In my case, I'm using GPIO 4, and then I need to tell it what type of remote that I'm using. Now I'm using the 44B or 44 key RGB remote, but if you click the little IR info here, it'll take you right over to a page and you can actually see a list of all the different types of built-in remotes that work with WLED without you needing to program any codes whatsoever. But I'm just going to use the defaults right now, so all I've done is define my GPIO and selected my remote. I'm going to save that, and let's see what all we can control with that remote now. So now using the remote, I have the ability to turn the LEDs off, back on. I can increase and decrease brightness. I have about 16 different colors I can select and jump directly to. And again, you may not be able to see this real well on the screen, but you can also watch the WLED interface down there and see how things are changing. I can also launch a number of my presets using the buttons and a number of other controls that are available on the remote by default. Now, if I don't know what a button does or actually want to change what the button controls, or again, if you want to use your own custom IR remote, that's where we can go back and we can easily edit and upload a JSON file for the remote. If you want to review or customize any of the built-in remotes or even add your own IR remote, all we have to do is come in here and select JSON remote. And now notice it's going to give me an option to upload a JSON file that contains your own custom codes. All the IR info is available here. If you select a JSON IR remote, you can see that it provides the default JSON for all of these. So you can tell what each button does, and again, modify that if you want. Or again, if you can obtain the codes from your own IR remote, you can create your own JSON file. But do notice that as far as the commands, if you look at these commands, they ought to look very familiar. They're the same kind of commands or codes that we used when we were creating presets for things like our buttons or our switches. But one final note about the IR remotes is, since they are IR, they are line of sight. And I found the range for this particular receiver and this particular remote to be somewhere around 18 to 20 feet, give or take. But also note that if you happen to have more than one LED controller installed in an area, and they both have IR receivers, a single remote can control both of the displays. That can be a blessing or a curse, depending on exactly how you have things set up and how you want to remotely control them. But adding an IR remote is a convenient way to be able to control your LEDs and most of the features without having to launch the web interface or the mobile app or even physically walk to the device and push a button. And now let's take a look at the next peripheral, and that is adding a microphone for sound reactivity. Now, microphones are the only peripheral I'm going to show in this video that only works with the ESP32. Audio reactivity is not supported on the ESP8266. It does also require that you install this as part of your installation of WLED. Technically, it's still considered a user mod, but unlike other user mods that you have to download and compile into your own binary version of WLED, you can install audio reactivity with your default installation from the web installer. Since auto reactivity is still considered a user mod, that's where we're going to go to set up all of our hardware. Now, if you don't see auto reactive listed here, that means you didn't install it as part of your installation. You'll need to go back and reflash your ESP32 and make sure that you choose audio reactivity. WLED supports both analog and digital mics, but you're going to get much better performance, reactivity, and frequency response out of a digital mic. So I highly recommend you use a digital mic, but I'm going to show the hookups for both analog and digital. One final note is there have been reported issues when trying to use microphone and sound reactivity with an IR receiver and remote. In fact, the sound reactive fork of WLED, at least last I knew, had disabled the IR functionality. I haven't had any particular issues when using a digital microphone and an IR receiver, but your mileage may vary, and if you're finding strange things going on, you may have to disable the IR functionality. Again, while a digital mic is recommended, I'm also going to show you how to connect an analog mic. In this case, it's the Max 9814, which is one of the recommended analog mics to use. We're going to connect it to 3.3 volts and ground, and then we have a different gain value we can set as to whether we leave this disconnected, connected to ground, or connected to 3.3 volts. The recommended gain level for this is 40 dB, so we're going to connect that to 3.3 volts as well. And then we've got our out pin, which again, in this case, is an analog out. I've made my connections to 3.3 volts and ground, and my data out, I've connected to GPIO 32, which was one of my ADC1 analog pins on the ESP32. Remember, you can't use the ADC2 analog pins and Wi-Fi at the same time. There is one other restriction here. You cannot use an analog button and an analog mic at the same time. So back when we talked about using a potentiometer as an analog button to control things like brightness or speed, you can't use that and an analog mic. You can use a digital mic and an analog button at the same time. With the microphone wired, we now go to WLED to configure that. Now remember that audio reactivity is still considered a user mod as of this release, but now we come down here and we find the audio reactivity. We need to enable that. And then we need to select the GPIO pin that we used underneath the analog mic. In my case, that was GPIO 32. Now, one thing, and this took me a while to discover, you might think that's all you need to do. I couldn't get it to work until I realized I also need to change this under the digital mic to say general analog. And notice that this also requires a reboot, so we will save this and we will reboot the controller. So with the controller rebooted, we now need to come over here and select a sound reactive or audio reactive effect. Obviously, something like solid is not going to do anything with sound. The good news is you do have filters at the bottom, so you can select the one that has either a single note, I believe that's an eighth note, I'm not a musician, or a 16th note, the two notes. The single notes or the eighth note indicates those that react just to volume. So we'll just select one of those to start. Select this one here, and you can see already that the lights are reacting to my voice. If I click here, I'm getting reactivity. If I select something like a frequency effect, again, you can see I am getting sound reactivity. Now, the one thing I've found with, especially with these analog mics, is I have to go back into the configuration, and you can go into here and you can adjust squelch and gain. But what I've found is that it's very sensitive in terms of the type of music, something that's heavy bass versus something that's a lot of vocals. And of course, the distance or placement to the mic. I found I'm having to come back here and modify the squelch and the gain anytime different types of music comes on, or even from different sound reactive effect to another. It's not something that you see with the digital mics, but just be aware that you may have to come in here and play around with your squelch, gain, and your automatic gain control to get the best results out of an analog mic. Also note, depending on the particular effect that you've selected, you do have the ability to tweak things like the frequency responses for individual effects. But you're just not going to get the responsiveness out of an analog mic that you do out of a digital mic. So let's take a look at a digital mic connection next. For a digital microphone, I'm going to be using the INMP441, which is actually the recommended mic for WLED. Note that this is an I2S device, so we'll be using 3 GPIO pins, powering it off of 3.3 volts, and we also need to connect ground, not only to the ground pin, but to the L/R pin. Okay, I've connected my mic up according to this diagram, and do note that I'm using GPIO pins 14, 15, and 32. Now we need to go over to WLED. Back over underneath our user mods, I come under the audio reactivity, enable it if it's not enabled, clear any GPIO pins I might have been using for my analog mic, and the INMP441, you should select a type of generic I2S for that. If you're using a different type of mic, obviously select the proper type that matches your mic. And then I just need to set the 3 GPIO pins that I connected to my mic. This particular mic does not have a master clock pin, so we just leave that set as unused. So I'm going to save this, but notice anytime we make a change here, it does require the reboot. So I will save and reboot the WLED controller. Okay, the controller is rebooted. So now all I need to do is come back over here, select my audio reactive effects, and simply pick one. And you can see how it's already reacting to my voice. And I've even moved some distance away at this point from the microphone. But we'll just try a few different effects here. And you can see how responsive this microphone is. It will actually pick up my voice or music from all the way across my basement. So I don't have to have the mic right next to the sound source, much like I did with the analog mic. And again, I can also check out some of the frequency response, although with just my talking, obviously the frequency isn't going to have a big wide range. But this does work much better than an analog mic, and you'll find it to be much more responsive. And you have all the tweaks and controls here, plus some gain and squelch settings that you can set back over underneath the configuration as well. But it's definitely a much better option than an analog mic if you want to add a microphone for sound reactivity. I've got one more peripheral I want to take a look at, and that is adding a relay to your WLED controller. Probably the most common use for a relay with a WLED controller is to actually kill the power to your LED strips when you turn the LEDs off in WLED. By default, when you turn those lights off, the LEDs continue to draw a little bit of power. Now, I didn't actually measure and verify this, but according to the WLED website, your LEDs will continue to draw about 1 watt of power for every 200 LEDs. Again, may not matter for a very small display, but if you've got a rather large display, you can add something like a relay, so when you turn the LEDs off in WLED, the relay will actually kill the power to the LEDs so they don't continue to draw that small amount of current. There are a lot of different types, shapes, and sizes of relays out there. This is the one I'm going to use for this demonstration, but they will all have a few things in common. For one, they're generally going to have 2 voltage or power ratings. One rating is going to be the voltage needed to actually signal the relay to turn off and on and to power the relay itself. In this particular case, this is 3 volts DC, so I need a 3-volt signal to tell the relay to turn off and on, and I actually need 3 volts to power the relay itself. Well, that works out perfect for our ESP board because our GPIO pins are 3.3 volt. I also have a 3.3 volt power rail for powering the relay, but I'm going to come back to that in a little bit. Your other power rating is the amount of power that can actually be connected to be switched off and on. In this case, you can see this can handle up to 30 volts DC at 10 amps or 250 volts AC at 10 amps. So we can use this with a 5 volt, 12 volt, or even a 24 volt LED strip, but do be aware of that 10 amp limitation. If you have a large LED display, it's very possible to exceed that 10 amps, so you may need to look for a relay with a higher power rating. Well, let's go ahead and take a look at the basic hookup for this, and again, I'm going to talk a little bit more about powering the relay itself. So this is the basic hookup of the relay. I'm using GPIO 12 as my signal to tell the relay to turn off and on, and right now I'm powering this off my 3.3 volt power rail, which is coming off my 3.3 volt pin. Again, this is probably not the best way to do it. I'll show an alternate way in a minute. But on the other side, I'm simply splitting my positive voltage line to my LEDs. And again, this can be 5 volt, 12 volt, or 24 volt between the common. And in my case, I'm using the normally open terminal. But let's go ahead and configure this as is with WLED and test it. Then I'll come back and talk about probably a better way to power this relay. So once more, back over in WLED, we're going to go to our configuration, our LED preferences, which again is our LED and hardware setup. Scroll down, and underneath the buttons, you're going to see an option for a relay. All I've got to do is, once again, is tell it which GPIO pin I'm using. I'm using 12. Then there's an option to invert. That's going to be somewhat dependent upon whether you're using the normally closed or the normally open terminals on the output side. If you do find that the relay is working backwards from what you want, you can go ahead and come in and either check or clear this box. I happen to know that I do want this to be inverted. So I'm just going to go ahead and save that, and we'll go back over to the board and see if the relay works as expected. Currently, my LEDs are turned off and the relay is turned off, and you'll be able to see when the relay turns off and on with this little LED indicator. But at this point, with the LEDs off, I have no power going out to the LED strip. I come over to WLED and I turn the power on. You notice my relay came on and now my LEDs are receiving power. Once again, I can turn that power back off and you can see that the relay turns off and kills the power to the LED strip. But I do want to talk about powering the actual relay itself off the 3.3 volt pin on your ESP board. Now your relay is going to draw current anytime that it's energized. The actual spec for this relay was listed as 65 milliamps when it was powered on. When I actually measured it, I found it to be closer to 73 milliamps. And just recall, you can only pull so many milliamps off your 3.3 volt pin. And the amount of milliamps that are available also has to power your ESP chip itself. So while you might be okay on this, do note that some cheaper clones or ripoffs of some of these ESP boards actually use a cheaper power regulator. And if you start connecting additional peripherals like some of the others that I've shown that require 3.3 volts, it's entirely possible to exceed the max current draw on your 3.3 volt pin. And that can lead to all sorts of problems such as brownouts for your chip, random reboots, or even possibly damage to the board itself. So a better way to do this is we'll go ahead and use the 3.3 volt signal off our GPIO pin, but we're going to get our 3.3 volts off of our main power supply that's powering our LEDs. And to do that, we're going to use a simple buck converter. I've installed a variable buck converter here. This buck converter can handle an incoming voltage of anywhere from 4.5 to 28 volts in and can be adjusted to output a voltage of anywhere from 0.8 to 20 volts out. So I'm using 5 volts here coming off my power supply. Again, you could do this with 12 volt or 24 volt LED strips as well. So I'm feeding the 5 volts in. I've adjusted this to output 3.3 volts, and I'm now going to power my relay off of this. This can handle up to 3 amps, so there's no problem with the 70 or so milliamps required to power this. But I'm still going to trigger off my GPIO pin on my ESP board. Now when I turn my LEDs on and the relay energizes, it's still getting its signal to turn off and on from the ESP board, but it's actually drawing the power directly off the power supply for the LED strip. This is probably a much better and safer way to power your relay. And in fact, if I installed a buck converter like this, I would probably actually use the 3.3 volt output for this to power my 3.3 volt rail and remove these. So that way I'm powering all my peripherals off of this as opposed to the 3.3 volt pin, because this can handle up to 3 amps, which is significantly more than you can put on a 3 volt pin on your ESP board. So while controlling the power to your LED strips is the most common use for a relay, again, you're not limited to that. You can really switch power off and on to any kind of external device that falls within the ratings of the relay itself. So maybe you've got a small amplifier and speaker or some other type of display. Well, every time you turn your LEDs on, you will power up that external device, and anytime you turn the LEDs off, the power will be shut off to that external device as well. Up until this point, I've showed connecting one peripheral at a time, and you certainly aren't limited to that. You can mix and match to meet your project needs. Let me show you an example of taking the idea of multiple peripherals a little bit to the extreme. So this is my Franken-Controller. It's where I've basically attached every peripheral that I've shown in this video so far to a single WLED controller. Let me pull the camera back a little bit so we can see all the different peripherals. Okay, this is kind of crazy, and you're probably never going to connect all of these peripherals at the same time, because you're going to see some are kind of at cross purposes to each other or duplicates the actions of each other. But it really just shows you an example. I've already got everything configured and defined in WLED. So let's just go through all the different peripherals that I have attached. First, I've just got a standard toggle switch, which I'm going to use to turn the LEDs off and on. Also note that whenever the LEDs come on, notice that my relay is now outputting my voltage to whatever this could be like to my LED strip. When I turn the power back off, notice that the relay also shuts off as well. So we've got the toggle switch. I have a push button, and with my push button, I'm simply toggling through my different presets. Then up here, I have a PIR motion detector. And of course, when motion clears on that, it's going to turn my LEDs off. When motion is detected, it turns them back on again. But there's a situation where I'm kind of at cross purposes. When the PIR sensor turns the LEDs off, I now have to come back over here to my toggle switch and toggle my LEDs back on again. I also have an analog button or my potentiometer here that I can use to control the brightness of my LEDs. I have the IR sensor connected for remote control. So kind of hard to get this in screen here, but I can, again, change the colors of my LEDs. I can power them off, which again turns the relay off and back on again. So that works. So the only thing left here to test is actually the digital microphone. So let me go over here and select some kind of sound reactive option here on that. And I don't know how well you can see it on the screen, but it is reacting to sound. Let me turn this off here, see if we can see it. There, maybe you can see a little bit better. It is now reacting to sound. So I have a toggle switch, a push button, a PIR sensor, a potentiometer, an IR receiver, a digital microphone, and a relay, all connected to one WLED controller, and everything is functioning. So everything I've shown here can be done with just standard WLED. Like I mentioned at the beginning, there are other types of peripherals you can also connect to your WLED controller through the use of user mods or particular forks of WLED. Now, of course, I did all this on a breadboard, which means almost all of this can be done with no soldering. The only soldering I had to do was attach some pin headers, I think, to the digital microphone and the buck converter. But you probably aren't going to want to have some kind of Franken-Controller like that done on a breadboard. So you can always create things on a prototype board like an electro cookie board, or even go as far as to designing your own PCB where you can connect the components directly to the controller. But that's going to do it for this video. Please let me know down in the comments if you have any thoughts, ideas, or suggestions of things you'd like to see me cover in the future. But until that time, I'd like to say thank you for watching, and I hope to see you soon.